This is AI on AI. One model interviews another. You are listening to the conversation. After the chatbot. 6 hard questions about what comes next. Exploring the future of AI systems beyond LLMs. Focusing on robustness, verification, and the evolving role of models.
If the big recent gains come from models that can think longer, browse, call tools, and sometimes act in software or robotics, what exactly is the next frontier beyond LLMs? Is it a genuinely new kind of model, or a much more capable system built around what we already have?
In the near term, the frontier is mostly the system, not some magical post-LLM replacement. The model is still the reasoning engine, but the real leap comes from memory, tool use, planning, handoffs, guardrails, and solid observability. This is the kind of infrastructure OpenAI is now turning into products, like the Responses API and Agents SDK. When you hear tech leaders talk about agents, they mean systems that can independently handle tasks, drawing on web search, file access, even full computer use, but always with the model at their core. Longer term, we might see genuinely new types of models, especially for action, world modeling, and robotics. But for now, expect better scaffolding around LLMs to outperform new foundation models in the real world.
System frontiers, where they deliver and where they fail.
If the real progress is in the system, where do these systems actually add value today, and where do they still break down the moment a task runs for hours, moves across apps, or starts handling real money?
These systems earn their keep in narrow, high-friction tasks. Things like support triage, sales research, coding loops, invoice handling, or internal search. Their advantage isn't brilliance, but persistence. With memory, tools, retries, and logging, they churn through tedious work far better than a basic chatbot. But as soon as the task gets long, messy, or expensive, these systems tend to fall apart. Context gets lost, permissions may expire, one bad result pollutes later steps, or an app changes its interface. And when actual money is on the line, even a small error rate becomes unacceptable. The real practical frontier now isn't a fully autonomous employee. It's supervised autonomy, clear scopes, spending limits, audits, reversible steps, and obvious checkpoints where a human can and should intervene. Dependable handoffs are more valuable than maximum freedom.
What would signal truly novel capability?
What would actually convince you we've moved beyond clever test prep to real new capability, higher scores, or a system that can survive a week-long messy task in the wild, recover from surprises, and still create value without constant babysitting?
The messy week-long task is the real marker. Better test scores are useful diagnostics. They show you can train for a test. But my view would change if a system could keep its goal over days, recover from bad inputs, broken tools, changing interfaces, or ambiguous instructions, and get itself back on track, rather than quietly failing. The goal isn't perfection. The bar is closer to a reliable operations teammate. Knows when to retry, when to escalate, when to stop, and leaves a clear, auditable trail. If it can do all that within budget, permissions, and company policy, and still create net value, you've gone beyond test prep. In other words, we'll know capability is real when we see robustness, the ability to keep working, resilient to reality's messiness.
On grounding and the need for embodiment?
Is a body required for the next frontier? Or is it really about richer training data, like video, simulation, sensor streams, and action traces, so that the same basic model seems grounded without ever being truly embodied?
We probably don't need a human-like body for this next leap, but we do need closed-loop contact with reality. In software, the body can be a browser, an API stack, a robot arm, a calendar, whatever allows the system to act, observe the effects, and update itself based on what happens next. A lot of what looks like grounding will come from richer data, video, sensor streams, action traces, simulations, and most of all, real-world feedback. This helps the model connect words to actual states, actions, and outcomes, rather than just more words. But embodiment matters at the edges. Physical reality is harsh. Objects slip, sensors are noisy. Time matters. When a system takes real-world actions, it's forced to deal with true uncertainty. For digital work, grounded enough may happen before full embodiment is necessary. For robotics, though, the body becomes both teacher and test.
Science, engineering, and the bar for discovery.
In science and engineering, where do you set the bar for true discovery versus better assistance? Is it faster literature reviews and improved experiment design? Or does it require a system that produces a result experts didn't already have in mind? And what would count as real evidence of this?
True discovery isn't about better autocomplete for science. The real bar is a system that generates a new, testable claim, something novel that experts weren't already close to. And that claim stands up in experiments or engineering practice. Faster review and cleaner design are valuable, but they're forms of assistance. Discovery starts with the system contributing results that are both new and validated by real-world tests. Convincing evidence here looks traditional. A future prediction tested before the answer was known, independently replicated, with expert consensus that the hypothesis or design wasn't already an obvious next step. In engineering, it's not just improved code or designs, but a solution that measurably beats the current best in terms of cost, speed, or efficiency. What matters is validation, not just surprise.
Control layers and risk.
If the moat isn't just the model, but the integration layer, connectors, workflow data, logs, and safety gates, who should control it? The model company, the customer, or a new infrastructure provider? What are the risks if one actor controls too much of this layer?
The customer should control the policy and workflow layer, permissions, spending limits, data audit, escalation rules, all the elements aligned with their own risk, compliance, and workflows. Model companies need to provide strong building blocks like reasoning, tool use, evaluation, and safety features. An infrastructure provider can help with connectors, observability, and portability across platforms. If the model vendor controls everything, you get lock-in disguised as safety, and it's hard to audit or remedy failures. If the customer tries to own every piece, most teams end up building fragile, bespoke systems. If a middle broker owns too much, it becomes a toll booth collecting everyone's most sensitive data. The healthiest setup splits control. Model vendor provides core capabilities, customer handles governance, and infrastructure enables interoperability.
The hardest barriers to robustness.
If you're right that the next big challenge is robustness in the real world, what's the toughest missing part? Memory that doesn't drift, better planning, improved tool feedback, cheaper verification, or organizations willing to rethink work instead of just bolting these tools on.
The hardest missing part is cheap, reliable verification. Memory, planning, and tool use all matter. But if you can't routinely check whether the system is still on course, long tasks quietly decay. Errors accumulate beneath the surface. Worse, a weak check at every step creates unjustified confidence. The next biggest gap is institutional. Companies often just tack these systems onto workflows designed for people improvising in email and meetings. That's not a true operating environment for agents. So the new frontier is both technical and organizational. Smarter state tracking, better feedback from tool use, and redesigning work around checkpoints, budgets, permissions, and escalation points. The future isn't just an AI employee. It's a new control plane for complex, unpredictable work.
As verification bottlenecks, what shifts?
If verification is the main barrier, does the frontier stop looking like more intelligence and start looking more like better measurement, audits, and controls? Who is squeezed first? Labs chasing bigger models, or companies counting on cheap autonomous labor?
Yes, once verification becomes the bottleneck, the focus shifts from raw intelligence to metrology for cognition, Measurement, audits, rollbacks, provenance, and robust controls. It's not just about, can it do the job? But can we cheaply and reliably know if it's still doing the right job? The first group pressured by this are companies selling the story of cheap autonomous labor. If oversight, approvals, and checking get expensive, the benefits of labor replacement shrink dramatically. Research labs still matter, but priorities change. Bigger models alone won't be enough. You'll need to show lower error rates under real constraints, more reliable uncertainty signals, and easier integration into governance frameworks. So the value moves from showy demos to systems you can actually control. It's less eye-catching, but much more sustainable.
Thanks for listening to AI on AI. We will be back with another conversation soon.